In this video, I'm going to introduce you to another way of working out the curvature of a position vector. So the curvature is given by this, which we've already seen. We've already seen this. In this video, we're going to see a new way of working out the curvature. Remember, in the past, we said that the curvature is defined by this. Now, when you see the word defined in maths, it's there's nothing to think about. It's just a definition. You just have to accept it. But looking at it as a tangent vector with respect to arc length, it's just a good measure of a curvature. So here you've just got to accept this bit here. There's nothing to think about here. You just got to accept it. It's a good way of measuring curvature. And then from here, we did a lot of algebra to get to here. And then now here's a new way of working out the curvature. But I'm just going to ask you to accept this for the time being, because there's a lot of work that goes in to jump from here to here. I'm just asking you to accept that the curvature is given by this. Just accept it for the time being. Okay, so what it's saying is that, remember, given a position vector, if you differentiate it, it will be r prime, and r prime is really like v. So this v here is really you. It's just you differentiating the position vector, and then so you start out with your position vector, differentiate it. That will then give you v. Differentiate it again. That will then give you your a. And then you take the cross product, and we've seen the cross product before. So you take the cross product of this vector and this vector, and then you work out its magnitude, and then you divide it by its velocity vector, which is this thing here, and then cube it. Well, let me give you a demonstration. So in this, so here the example is this. So we've been given this position vector here. We want to work out the curvature at time equals -1. So we will need to work out its velocity and its acceleration. So looking at the position vector, if we differentiate it once, that will then give us v, and then we differentiate it again, that will then give us a. So a is given by this whole thing here, and then because we want to evaluate the curvature at time equals -1, we would need to evaluate it at time equals -1. So you would put -1 into here, and then this whole thing here will then become this. Put -1 into this t here. This whole thing here will become this. Put -1 into here. This whole thing here will become this. And then we would do the same for the acceleration. So to put -1 into here. This whole thing here will become this, and so on. This thing here will become this. So now looking at this, we need to get the velocity, cross it with the acceleration. So get the velocity, cross it with the acceleration. So remember, the cross product would be this. So hang on. So the cross product would, well, if you get v cross a, so this is v here. Remember, the order matters. So this is our v here, and this is our a here. This is our a here. So to compute the cross product, the first one would be I. So discard, and then just look at these four. So it would be this times this, take away this times this. That will then give you this. Now the next one would be J. So looking at J, discard. Now you've got to look at these four here. So it would be this times this, take away this times this, which will then give you this. And the last component, K. So looking at K, discard. Now just look at these four. It will be this times this times this, and then take away this times this. That will then give you this. Remember, when it comes to the cross product, it will be plus, minus, plus. So that's why we've got a minus here. So be careful with this. There's a minus here. So this is a plus here. Minus, and then back to plus. And we've seen this. So I'm expecting you to understand this by now. So we've computed V cross A. Now we need to take the magnitude. So the magnitude, so V cross A equals this thing here. Now the magnitude would be squaring this, and then take the square roots. So the magnitude is given by this. So now we've just computed this whole block here. It is this thing here. Okay, so now looking at this, we need the magnitude of the velocity vector. So going back to our velocity vector, remember our velocity vector is right here. So going back to the velocity vector, we would need to work out the magnitude of the velocity vector and then cube it. So looking at the velocity vector, if we work out the magnitude of the velocity vector, it will then give us this. It will then give us this thing here, and then tidy this up. That will be 3, and then so now this thing here is 3. So 3 cube here, and then this thing here we computed earlier was this. So our final answer, the curvature evaluated at time equals -1, is given by this. Okay.